Tool scripts are a gateway to making Godot plugins, and once you know how to make your own plugins, the game dev possibilities open up. Cooler still is that getting started really isn't that hard. You probably just need someone to take the first few steps with you. So in my next couple of videos, I'm going to explain how I went from using tool scripts to toggle sprites on objects to developing Babel Mocha, my first full-blown plugin for creating branching dialogue paths for my game, Bermuda Moon. In this video, I'm going to explain what tool scripts are and share some real-world examples showcasing how they can automate scene setup. That foundation will make moving into plugins in the next video no more than a hop and a skip. No jump required. Everything in this video is running in Godot 4.5. So what are tool scripts? Well, let me show you using my favorite demo scene, a giant centered label. When I hit play, you're going to see that this is nothing more than a frame counter. Okay, so I'm going to close that out. We're going to pull up the script, and there is nothing weird here. We're just incrementing an integer each frame and printing its value to the label. Nothing out of the ordinary. Now I'm going to add a tool property to the top of the class, and I'm going to save this out, go back to Godot, build our project, and then just real quick I'm going to reopen this scene, and I didn't hit play. This counter is running in the editor, and my script icon is turned blue. What black magic is this? By now you know underscore process runs once each frame. The logic you put there gets resolved, and then a new frame is rendered to the screen. How do you think the Godot editor handles frame updates? How do you think other computer programs do it? That's right, in exactly the same way. Every computer program, including the Godot editor, has a frame update. And in Godot, if we mark our script as a tool script, as long as it's somewhere in an open scene, Godot will scoop it up and run it alongside all of its other built-in engine code. Enter tree, ready, exit tree, and other standard methods also fire and can lead to your own methods, opening the door for some fun shenanigans. The first step to understanding tool scripts and plugins is that paradigm shift. That Godot, the computer program, and by extension other computer programs, are no different than the games you've been making. They run code in similar ways, so you can affect what happens in the Godot editor using code you're already comfortable using. Think of Godot as a really UI-heavy game, and you're starting to get into the right headspace. Now for some real examples from my game to show you practical applications of tool scripts. Here's a palm tree. There are many like it, but this one is here. They exist throughout my game world, can be in daytime or nighttime stages as decoration and as segment borders. If I want a stage that takes place both during the day and night, it's far easier to swap the art of a pre-existing object than it is to build one from scratch. So over here in the inspector, I have places to load day and night versions of the art, and a toggle for changing which one is displayed. Basic, but a great entry point for understanding tool scripts. Let's look under the hood. To access the toggle functionality, I use the power of C# properties. If you're unfamiliar with C# properties, I have a video on them linked in the description. In a nutshell, properties are like if variables and methods had a baby, and they allow you to run code when the property's value is set or retrieved. For our GDScript friends who may be following along, you can use exported getters and setters for achieving what I'm doing with properties here. So look that topic up if you're unfamiliar. If you watched my properties video, you know my isNight property is nothing special. For the get, we're just returning our storage. Set is where the real action happens. I'm setting our storage as one would, then I'm running this line that uses a ternary check to assign the correct sprite. There's no voodoo that makes this work. If you were to change the value of that property in the game, the visuals would change in the game. Just now it's running in the editor. So when you change the value of the property, just this time in the inspector instead of code, it acts as you'd expect. Taking this principle just one step further, I've got this fire pit. Once again, there are daytime and nighttime versions, but I can also choose to set it alight or keep it extinguished. This script runs on the same principle as the palm tree. Boolean properties act as switches in the inspector, only these ones call methods instead of doing their work inline. And just like the palm tree, it's all very basic, just slightly more involved because I'm setting the art from a sprite sheet instead of just swapping images wholesale. And yes, I am using magic numbers, and yes, that is super gross, but since I never have to touch this script again, I don't really care. Those are tiny examples, and they're more quality of life than necessary or time-saving features. You know what is a time-saving feature, though? being able to swap full tile maps, collision and all, at the push of a button. I mean, that's pretty sweet. And since you're doing this in the editor, these are persisting changes, a huge time saver for stage variants without having to mess around with shaders. Assuming all of your tiles on a given tile map layer come from the same atlas, and both atlases you want to use exist in the same tile set, you can swap between them using this code. We're in a tool script, obviously. We use a Boolean property to act as a button, and if we're not locking our ability to toggle in set, we change our storage field's value and call the method that changes the tiles. We return out if we don't have to do any work, but if we do, we determine which atlas is being switched to. We then loop over all of the cells in the tile map layer. If that cell already belongs to the atlas we're switching to, we just ignore it. Otherwise, we get the corresponding tile coordinates, get its rotation and mirroring data, and set the cell with its equivalent on the other atlas. Now you tell me, if you knew how to write this code, would you rather do this or build that giant tile map again from scratch, also keeping in mind that this code is reusable? That's right, tool scripts, baby. The one part of this script that might not seem so straightforward is this variable, and its use here. So let me clarify. When you're new to tool scripts and using them for setup tasks like I just showed you, you're likely to run into some very weird behavior. Things just won't act like you'd expect, and some of your tool scripts will set and reset things at odd times and in weird ways, and it can get frustrating. Fortunately, it's always one of two potential culprits. The first is not handling Godot message functions properly, while the second has to do with the way Godot handles C# properties. Let's first focus on the Godot message functions, meaning those methods that are called automatically during the life cycle of your node. Here is a nothing tool script that prints messages to the console during enter tree, ready, and exit tree. If I go back to Godot and I open up the scene that contains this code, you can see that enter tree and ready fire here in the editor. If I close this scene, exit tree also fires. Because Godot message functions fire automatically in tool scripts, you need to be wary if you're doing any sort of setup or resetting in these methods. That setup will run in the editor, and you may not always want that. Adding this line to the top of your message functions will prevent them from firing when you don't want them to. Engine.IsEditorHint returns true if the script is running in the editor, so placing this line at the top of these methods will allow them to work in your game, but it will save you from running into any issues when you're navigating the Godot editor. That covers handling message functions, but being C# users, we also have to account for how Godot processes properties. When a C# script is loaded into memory, Godot will automatically run the sets on any properties in the open scene. Of course, if you're doing setup via these sets, they'll run, and you'll get similar weirdness to not handling the setup in the Godot message functions. That's why I'm using this lock toggle variable here. It allows me to open and close my tile maps without them resetting themselves on open or close. I don't want to use the Engine.IsEditorHint check I showed you for the message functions because I do want this to run in the editor, just sometimes, not all the time. When I want to toggle the atlases, I just unlock my ability to do so, swap them, and lock things back down. This method for protecting your setup is especially useful when the visuals get super crazy like they do when I'm setting up my island or NPCs. This is all done using the same principles I just showed you, just at a larger, slightly more complex scale, where sprites, animation properties, and shader values are all being set via the inspector in my NPC Islander script. Now for something I haven't done in ages, I'm assigning homework. There's nothing like a little homework to help you engage with the material at a deeper level, which will eventually destroy your need for tutorials altogether. If you understand the content in this video, you 100% have the knowledge to complete the homework. You just need to believe in yourself. So here we go. Two other spots in my game I have found tool scripts to be immensely helpful is in setting up waypoints and movement ranges for my enemies and NPCs. They allow me to visualize things in a way that the built-in tools can't, and because it's my personal code, if I ever want to expand the functionality or make it more specialized for a future game, I can do that with minimal difficulties. So I want you to pick one of two challenges. Develop a box range scene or a waypoint manager scene. The waypoint manager challenge will be slightly more complex than the box range, but they're both the same in terms of difficulty. For the box range, give it all of the properties I'm showing here: width, height, horizontal and vertical offsets, draw color, and a toggle. For the waypoint manager, use these properties: an array to hold waypoint positions, width and height of the waypoints themselves, draw color, and a toggle. All the box range needs to do is draw the box as you'd expect according to the properties while it's running in the editor. Same for the waypoint manager, but that'll draw little waypoints instead of a box. Once you have these set up, they'll be a fantastic foundation for setting up your own 2D movement system. So real quick helpful hint with this is you're going to want to utilize Godot's built-in _draw method to handle drawing the gizmos. And just to make things easy on yourself, assume that these are going to be child scene components, so their drawing is going to start at their parent's origin, or 0, 0. By now, tool script should seem pretty basic, and the idea of making a plugin not nearly as far-fetched as it was at the start of this video. Tool scripts are useful and powerful, but not without their limitations. For instance, no physics methods are called in the editor, so you're not going to have a good time making a platformer that runs in the viewport, but some crazy internet person could do it. For cosmetic changes, scene setup, and visualization through gizmos, though, top-notch. In the next video, which by the time you see this one I'm already hard at work on, we'll expand on the concepts here and I'll walk you through building a very basic plugin, and then I'll explain how you can expand that to build tools that work for you, by you. In the meantime, the best to you and yours, and I cannot wait to see you again. Take care.